test to see exactly how long it takes the rapid charger that comes with the Milwaukee M18 fuel lawnmower to charge the M18 12 amp hour HD batteries. Okay, we're going to start. Make sure kilowatt meter is fresh. Charger's just drawing its standby just under 1 watt and 0 kilowatt hours drawn. Connect up the batteries. These are both dead. Drain to the point of shut off. Charger is currently drawing 242 watts. And we will just do a sped up video from this point forward until the end, because I doubt you guys want to watch in real time. If you do want to watch in real time, post in the comment section below and I will upload a real-time version. Don't forget, like and subscribe. Hit that thumbs up button. And I will leave power drawn, so total kilowatt or watt hours will be on the kilowatt meter. Fast forwarding now. Alright, so we're going to stop. We're at, well, it stopped about a minute ago, so roughly hour and 50, we'll say hour and 55 minutes. Charge rate was surprisingly high up until the end, and then it did a good drop that last bit. Now, volts times amps equals watts. Total 480 watts, so since this only goes 2 decimal places, we're at 480 watts to show. It doesn't get more accurate than that on the kilowatt meter. I don't know if you can see that there. There we go. A little disappointed at total charge time, given that this is a rapid charger that came with the Milwaukee $1,000 push lawnmower, well, self-propelled lawnmower. Now, Milwaukee does have one that's faster. I do not have a charger that's faster, but they have one called the Supercharger. I'm sure they got that idea from Tesla. The Supercharger is supposed to be even faster than the Rapid Charger. Personally, for a $1,000 mower, it should have came with the Supercharger, not just the Rapid Charger. Now, considering its price tag, the Milwaukee lawnmower is kind of marketed towards either those who are filthy rich, or maybe not, or lawn services, since a lot of Milwaukee tools are, well, designed for professionals. And professionals need the fastest charging available, so considering the size of these batteries, if I was a lawn service guy, either I'd have to spend another $1,000 on batteries to get 2 more sets of batteries, since you need 2 for the mower, or I'd have to get a supercharger and have it plugged into my vehicle and charge in between jobs. Thankfully, also, though, the capacity of these batteries, I was able to do my 1/3 acre yard in its entirety 4 times, which actually gave me slightly longer runtime than Milwaukee's estimated 1 acre of cut, and my grass was pretty tall the first couple times. Thank you, No Mo May. So if you think about it, I cut my lawn 4 times on 480 watt hours of electricity. That's pretty efficient. Now the 480 on there also includes any power losses from the actual charger. Because the charger does, and chargers aren't 100% efficient, so usually we say between 90 and 95% efficiency. So you have some losses in the fans, because this one is a fan-cooled charger. Some other things I noticed. Milwaukee advertises their batteries as 18 volt, which is 18 volt nominal. Whereas other manufacturers, such as DeWalt, advertise as 20 volt, which is 20 volt max, fully charged. So 4.2 volts per cell. So 4.2 times 5 is, well, actually 21 volts. You need 5 cells. So technically fully charged right now, these are 21 volts. Give or take a tiny tenth of a volt, a couple millivolts here and there. However, Milwaukee advertises 18 volt nominal. That's where you get the M18 from. Now, at the same time, they're kind of fudging numbers too, because they're not basing the 12 amp hours off of the 18 volts. They're basing the 12 amp hour capacity off of the fully charged voltage. Okay, so we had 480 volts, or 480 watts. We're just going to go based off a meter value. So it's volts times amps equals watts. So let's divide by 2. So we got 480 watts. We're going to divide by 2. That means each battery is 240 watts. I know I can do that in my head. I'm doing that for the visual reference. So to get amp hours, you take watts divided by volts equals amps. So 240 divided by 18 volts is 13.33 amp hours. So that means we're missing 1.333 amp hours of these batteries. But if we take 21, let's reverse it, 240 divided by 21, the fully charged voltage, 11.4. Or, since all the other manufacturers call these 20 volt batteries, 240 divided by 20 volts equals 12. 12 amp hours. 12 amp hours. So, while Milwaukee advertises as an 18 volt battery, they are basing the capacity off of 20 volts, the fully charged capacity, not the nominal advertised capacity. Just a little information there. I mean, in the grand scheme of things, these are still freaking huge batteries, and there is a lot of power here. That is a lot. This would be more than enough to jumpstart a gas car, diesel, so on, so on. Either way, great batteries. Yes, this is a rapid charger, and it's a simultaneous, so it doesn't charge one, then switch over to the other. A little disappointed that it took almost 2 hours to get a 100% charge for a $1,000 lawnmower. And this is $500 worth of batteries right here. These are about $250 a piece, shelf price. If you were to walk into Home Depot, grab one off the shelf, of course, plus tax. I still think for a few extra bucks that it would have cost them, the supercharger would have given a lot better bang for the buck, especially considering the price of this lawnmower. Yeah, it's right there. Garage is a little crazy at the moment. Yes, that is a Miss Pac-Man machine. So that's it. We'll say 1 hour, 55 minutes. And I'll go back and watch the video and see exactly when the batteries clicked off. The kids have me coming in and out of the house constantly, so good night, folks. Oh, I should do... When I drain these again, I am going to do another test using a standard charger. Not the Rapid, but a standard charger. I usually see about 60 or 70 watt charge rate out of those, compared to, well, with both going, I thought I saw just under 500. It was a little all over the place. They usually start out slow and then speed up. Good night.